Understanding the pH scale is an important part of this topic. The acids commonly mentioned are, from this end of the pH scale, hydrochloric, sulfuric and nitric acid. When neutralized, these become salts. If hydrochloric acid is used, we get chlorides, sulfuric acid gives us sulfates, and nitric acid gives us salts called nitrates. They are all around pH 7. Chemicals from the other end of the pH scale are able to neutralize the acids. The most common alkalis that can neutralize these acids are mentioned here: sodium hydroxide, potassium hydroxide and ammonium hydroxide. There are two main lab techniques used for neutralizing an acid. One is a titration experiment. This involves putting an acid in a burette and adding it carefully to some alkali in a conical flask until an indicator just changes colour. The solutions can also be put the other way around, with the alkali in here and the acid there, still with indicator present. There's a video that explains this already in the ITNG course. The second technique involves filtration because you're adding a solid to the acid and the solid has to be in excess and then removed afterwards. This time you don't need an indicator in the acid because the excess solid is there to make sure all the acid reacts. And again, already a video exists in the ITNG course which explains this whole technique in more detail. Another important aspect of neutralization reactions is that they are exothermic, which means that if you put an alkali into this acid in a beaker, in this case we have hydrochloric acid, adding an alkali will make the temperature rise as the neutralization reaction happens. A clever way of monitoring this temperature rise is to use some computerized apparatus with a digital thermometer into your mixture. The computer will track the temperature as it rises over time. So on the bottom of this scale we have time marked out in minutes, and on the temperature scale we have degrees centigrade. The highest temperature will be reached when the amount of acid and alkali are equivalent to each other. This is the point of neutralization, and the temperature will start to fall after that because you're adding a cold solution to the hot mixture. If you continue adding alkali to the acid. One final thing that's worth pointing out is that the reaction is exothermic whether you are using an alkali or a base to do the neutralization. So either technique, using a burette or filtration, will still give you a temperature rise. This diagram is from a past paper. It just happens to be a great way to summarize this topic as well. There are four main types of substances that can neutralize an acid. Three of them are solids, and so we'd filter when we finished. Only one of them is a solution, and that's our hydroxide solution over here, and that's called an alkali. We'll take a quick look at each of these things in turn. For a metal to react with an acid, it has to be above hydrogen in the reactivity series, only these metals. Anything below will not react with an acid. When the reactive metal is placed into this acid solution, we can see that bubbles of gas will form. The bubbles of gas are hydrogen. In this diagram we have magnesium, but in the question it's zinc. Either way, hydrogen is the gas that forms. So, in summary, we can see that zinc must be the metal, and we already know we're using hydrochloric acid. The gas must be hydrogen. If we are using sodium hydroxide solution, which is an alkali, in our burette, then we must have some acid in here as an indicator. If we repeat the titration enough times, we can leave the indicator out because we know how much volume we're going to use. And our colourless solution will be a salt and water. The name of the salt, sodium chloride, comes from both the alkali and the acid used. Copper carbonate is a green and insoluble powder, so filtration will be used this time. Copper carbonate is added in excess to the acid in the beaker. The excess copper carbonate left over after the reaction is finished is retained in the filtered paper, and the salt solution goes into the evaporating basin. Eventually, when all the water evaporates, just the salt is left behind. Carbonates always fizz when put into an acid. It's not shown in the diagram here, but is mentioned in this text box. Occasionally you're asked, what is the test with a carbon dioxide gas that comes from a carbonate? It's bubbled through lime water, and gradually the lime water becomes milky white. The only other material not mentioned that can neutralize an acid is a metal oxide, and we can see that copper is mentioned in the name of the salt, so it's probably going to be copper oxide. This picture shows that copper oxide is a black powder. The technique used to get a neutral solution is the same as for copper carbonate, which was a green powder. Copper oxide is added in excess, filtered off when all the neutralization has happened, the salt solution is collected, and then evaporation to leave the salt behind. The main difference between using copper oxide here and hydrochloric acid is that you get copper chloride, as you do with copper carbonate, and water, as you would get with copper carbonate, but copper carbonate also gives off carbon dioxide gas. And that's the summary of topic 5, with one quick question to finish. A gas was mentioned here. When a metal was put into an acid, a gas is released. The gas was in fact hydrogen. But what is the test for hydrogen gas in the lab?